Hi everyone. In this video we will start by learning this new notation and this new object which is called factorial of a number. So what is factorial of a number? Factorial of a number is basically saying multiply all the integers, positive integers, up until this number. Okay, so what does that mean? That's the notation. We read this as 3 factorial. This means what is 3 factorial is basically you multiply all numbers until the number 3, or another way to say that is you start with this number and you keep reducing until you hit 1. So this is 6. So similarly, something like 7 factorial would be you start with 7, reduce 6, reduce 5, reduce 4, reduce 3, 2, 1. And we are not as much concerned with what that number is for larger numbers because it increases really fast, but just a basic definition. And the next thing we are going to introduce is this notation which goes n r stacked on top of each other in parentheses. What this equals is n factorial over r factorial times n minus r factorial. Okay, so once you look at an example, it's going to make more sense. So here, just based on the definition that is given, this should be 6 factorial, then 2 factorial, and then 6 minus 2 factorial. So what's that? That's 6 times 5 times, or let me write one more step here. 6 factorial, 2 factorial, 6 minus 2 is 4. So this is 4 factorial. Now what is that? That's 6 times 5 times 4 times 3 times 2 times 1, stop. 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. But these are all multiplied and divide, so you can cancel things. So you notice that this entire chunk cancels out and this becomes 3. So this comes out to 15. So all of these are going to come out to be numbers. So basically, something or the other is going to cancel out. So 3, 0, this is going to be 3 factorial. 0 factorial, 3 minus 0 factorial. So that's 3 factorial, 0 factorial, 3 factorial. Now that brings us to the question of what is 0 factorial? We're going to define 0 factorial to be 1 instead of saying it is 0. Okay, so the only unique definition is that of 0 factorial, which we call 1. And also, by the way, this is how you read this is NCR. I will talk about why we have the C in between, what it means, and all of that. 9 and 3. So this is 9 factorial, 3 factorial, and 9 minus 3 factorial. So this is 9 factorial, 3 factorial, 6 factorial. Foiling this out, this is 9 times 8 times 7 times 6 times 5 times 4, 3, 2, 1. Then you have a 3 times 2 times 1 and a 6, 5, 4, 3, 2, 1. Once again, cancel of all of these. 2, 4, 3, 3. And what does that become? 3 times 4 is 12 times 7 is 84. So that comes out to 84. Oh, sorry, I didn't complete this. So 0 factorial is 1, and these are both 3 factorial, so they essentially cancel out. So they just become equal to 1. C4 is 4 factorial, 4 factorial, 4 minus 4 factorial. So 4 factorial, 4 factorial, 0 factorial. So it's kind of like this second one. You just switch the zeros and 4s. These cancel and this also comes out to be 1. So right now, we just learned what a factorial is. And we learned this weird thing which we call NCR and how to evaluate them. And in the previous video, we talked about the motivation behind the binomial theorem. So we can give the binomial theorem now. So basically, it combines both of these. So it says, if I take a plus b to the power n, right, what are my terms going to look like? Now, we had some observations. We said that there's going to be an a to the power n, there's going to be a b to the power n. And between them, the powers of a or x or one of them is going to reduce. And the powers of the other one is going to increase. The last thing that was left to be figured out is the coefficient, meaning the number that comes in front. Yeah, and to do that, we use factorial. So we get n choose 0, nc1, nc2, nc_n. And you can again see one of the observations we saw that these two are both equal to 1. So that the outermost two numbers, right, they do not give you any other answer. They give you just 1. They don't give you any other number. Now let's see this in action. Evaluate x plus 2 to the power 4. Now how we're going to set this up is we're going to write first term to the power 4, and then some ways away we're going to write the second term to the power 4. Okay, now what we're going to have the powers of x reduce. So x cubed, x squared, and then an x. But while this reduces, the power of 2 increases. So this is going to be 2 to the 1, 2 to the 2, 2 to the 3, and then 2 to the 4. So you have to make sure they match up to the endpoint. Now the last thing left to do is figure out the number. Now that number is 4c1, 4c2, 4c3, 4c4, which is 1. So we got to figure out these three. So go 4c1 is 4 factorial, 1 factorial, 4 minus 1 factorial. 4 factorial, 1 factorial, 3 factorial, 4, 3, 2, 1, 1, 3, 2, 1, cancel. This is 4. 4 choose 2, 4 factorial, 2 factorial, 2 factorial. 4, 3, 2, 1, 2, 1, 2, 1, cancel, 6. And lastly, 4 choose 3, 4 factorial, 3 factorial, 1 factorial, 4, 3, 2, 1, 3, 2, 1, 4. So you have all the numbers. Putting them together, you get x to the 4 plus 4 times x cubed times 2 plus 6 times x squared times 4 plus 4 times x times 8 plus 16. Let's do a little more simplification because we have these numbers that we can combine. This is going to be 4 times 2 is 8x cubed, 6 times 4 is 24x squared, 4 times 8 is 32x plus 16. So x plus 2 all raised to power 4, you do not have to FOIL everything out 4 times to find it. You can use the binomial theorem. Now let's look at a second example. In the second example, we have to be a little careful. Okay, we have to be careful about the negative y. So in order to make it simpler, what we are going to do is we are going to view this as 2x plus negative y to the 5. So that I'm going to treat 2x as my first term and negative y as my second term. So I'm going to have 2x to the 5 and at the end point negative 5 to the or negative y to the 5. I need to make the powers reduce, right? So I'm gonna have 2x to the 4, then a 2x cubed, then a 2x squared. I'm gonna move this, and then a 2x, and then finally this guy. And I need the numbers, so 5c, sorry, I need to also put in the y's. So powers of y now increase. So negative y squared. Oh, this is not enough space here. So I'm just going to write it all together so that I'm not crunched for space. 2 to the 5 plus 5 choose 1 or 5c1. The power of x reduces, but the power of y will now increase. So now we have 5 2, then 2x cubed negative y squared. Then 5 3, 2x squared negative y cubed. 5 4, 2x negative y 4. And lastly 5 5, which is 1, and then negative y to the 5. Okay, so it's a little more involved, this particular case. So what do I need to evaluate? We need all of these c's. So 5c1, 5 factorial, 1 factorial, 4 factorial, 5 4 3 2 1, 4 3 2 1, 5. 5 2, 5 factorial, 2 factorial, 3 factorial, 5 4 3 2 1, 2 1 3 2 1, which is 10. 5 3, 5 factorial, 3 factorial, 2 factorial, which is again 5 4 3 2 1, 3 2 1 2 1, which is also 10. And 5 4, which you will see is when you do this, it just comes out to be the same as this. So this is going to be 5. So you have these numbers. Now you just have to take the proper powers. 2x to the 5 means it's 2 to the power 5 as well. So it's 32x to the 5 plus 5 times 16x to the 4 times negative y. Then you have 10 times 8x cubed. Negative y whole squared becomes a y squared. Then you have 10, 4x squared and negative y cubed. Then you have 5 and 2x y 4, and then you have a negative y to the 5. Lastly, let's combine all of this and you get 32x to the 5. 5 times 16 is 80, but there's a negative. So let's go back and change this to negative 80x to the 4y plus 80x cubed y squared. Now minus again 40x squared y cubed plus 10x y 4 minus y to the 5. So again, let's check. A few of our observations have not changed. Power of x goes from 5, 4, 3, 2, 1, 0. Y goes from 0, 1, 2, 3, 4, 5. Now instead of all being pluses, they alternate between being plus and minus, which makes sense because there is a minus in there. And a negative times negative, odd number of times is still a negative, and even number of times is a positive. So that works out fine. Now, we're going to end this video here, and in the next one, we will see that, well, wouldn't it be nice if there was a better way to find these things? So we used a pattern to define these, and then we can find some patterns in these numbers itself. For example, here, why is this 5 and 5? Why is this 10 and 10? Like if I knew that beforehand, I would only have to do half the calculations, right? Similarly here, why is this 4 and 4? And why is this 1, 6, right? So there's another way to find these, which is called the Pascal's triangle. That's going to be the next video, which will also be the last one. Thank you.